In this video, we are going to look at compound angle formulae. Now, in trigonometry, we can have trig functions of compound angles. Compound angles are when two angles are added or subtracted. So, for example, we might have sine of an angle plus an angle, sine of an angle minus angle, and so forth. Right. Now, to do calculations with compound angles, we make use of these compound angle formulae, which allow us to, if we work from left to right, expand, or if we work from right to left, contract. Okay, so these compound angle formulae are going to become very useful to us, so it is important that you get to know them very well and try to, if you can, learn them off by heart. Now, to learn them off by heart, it's very helpful to study them in detail and try to pick up on the patterns that they have. Okay, so for example, if we look at the two sine formulae, okay, if we just read them quickly, I've got sine of alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. Then if we look at the second one, sine alpha minus beta equals sine alpha cos beta minus cos beta sine alpha. So the first thing I want you to notice is that in both of them, our first term in the expanded form has got both sine and cos trig functions. Okay, but if we move to the second term, we start with the cos and then the sine. So it's sine, cos, cos, sine, sine, cos, cos, sine. Okay. And the angles are in the order that they were in the bracket here. So alpha first, then beta. Again, in the second terms, alpha first and then beta. Okay. Now, if we look at the signs, as in the plus and the minus, we notice that if I have a plus in the bracket here, I have a plus in the expanded form. If I have a minus there, I have a minus in the expanded form. So for the sine compound angle formulae, the sign doesn't change. So the plus or minus doesn't change. Okay, if we now look at the two cos compound angle formulae, okay, if we just read them, I start off with cos alpha minus beta equals, and then I have cos alpha, cos beta. In the second term, so then I'm adding, I've got sine alpha, sine beta. Okay. If we look at the second cos function, I've got cos alpha plus beta, cos alpha, cos beta, minus sine alpha, sine beta. So for both compound angle formulae, I have in the first term cos, 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 and in the second term, just sine, sine. Okay. So notice the difference between the sine compound angle formulae and the cos compound angle formulae. What does stay the same throughout all four formulae is that my first angle in the bracket is my first angle in each term. The second angle is the second angle in each term. Okay, if we now look at the sign, so the plus and minus, notice that for the cos compound angle formulae, the signs are opposite. They change. So if I start with a minus in the bracket, I have a plus in the expanded form. If I have a plus in the bracket, I have a minus in the expanded form. So whereas for sine, the signs don't change, for cos, the sign changes. Okay. The more you study these and understand and pick up these differences, the more familiar you will become with these compound angle formulae, and the easier it will be to apply them. Okay. So what we are going to do now is work through different examples that show how we can use the compound angle formulae. So if we look at the first example, in this example we are going to look at how we can expand an expression or trig function with a compound angle. Okay, so it says expand the following, and for A I have cos x plus y. So if I look at the compound angle formulae in the box on the right here, I'm dealing with a cos trig function, so I've got two options, okay? But I have an angle plus an angle, so x plus y. In this case, my angle is x and my second angle is y. So I look at where do I have an angle plus an angle? It's in the last formula here. So I'm going to expand according to this formula. The only difference is that my angle is now not alpha or beta, but x and y. But I'm going to follow this formula. Okay, so cos x plus y is equal to cos. Then I put in my first angle, which is x, and then cos again, and then I have the second angle that was in the bracket. Then I have a plus in the bracket, but according to the formula, the sign changes to a minus. And then in my second term, I have sine, but now it's sine of the first angle is x, sine of the second angle, which is y. Okay, let's do another one. So just expanding. In B, I have sine A minus 60 degrees. Okay, so I have a sine compound angle. So I go to the sine compound angle formulae, and I look inside my brackets. I have an angle minus an angle. So I'm going to choose the option with an angle minus an angle in the brackets. Okay, so this option here. So the formula says this expands to sine of the first angle, cos of the second angle. So I write that down. Sine of the first angle, which is A, cos of the second angle, which is 60 degrees. Then I have a minus. So the same sign as in the bracket, a minus. And then it says the second term is cos of the first angle. So cos in this case, sorry, not x, cos of A, and then sine of the second angle, which is 60 degrees. All we had to do in this one was expand, so that's how we leave it. Right, a second way that we can use the compound angle formulae is to contract. So this would mean going from the right side of the formulae to the left side. Okay, so let's look at this example. It says, write as a single trigonometric ratio sine 45 degrees cos 15 degrees minus cos 45 degrees sine 15 degrees. Okay, the first thing I notice is that I have sine cos and then cos sine. So sine cos cos sine, that is part of my sine compound angle formulae. Okay, the next thing I want to check is, do I have the same angles? So if we look at the formulae, my angles are alpha, alpha, beta, beta. So I want to know, does the first trig function in each term have the same angle? Does the second trig function in each term have the same angle? And if we look here, I've got 45 degrees, 45 degrees. So the first angles are the same, and my second angle is 15, 15. So that's fine. So which one of these two sine compound angle formulae will I use? I will use the one with a minus sign. So I will use the second one. So going from left to right, this contracts as sine, and then in brackets I'm going to have the first angle minus the second angle. So that is 45 degrees minus the second angle, which is 15 degrees, and that can simplify to sine 30 degrees. And if you know your calculator, you can if you know your special angles, you can evaluate that quite easily. Right, so speaking of special angles, here is an example where we are going to contract and we can find the value without a calculator. That means we will use our special angles. Now, if we look at this example, it says, calculate without the use of a calculator. And we have cos of 320 degrees, cos of 20 degrees, plus sine 140 times sine 200. Okay, the first thing I notice is that I have cos cos plus sine sine. So that reminds me of the cos compound angle formulae that have cos, cos, plus or minus sine, sine. But the problem that we have is that our angles are all different. That means we need to use reduction formulae to change the angles so that we do have the first angles being the same and the second angles being the same. Because we cannot use a compound angle formulae if we don't have the same angles here. So we need to first do some reduction. So if I look at cos 320 degrees is in the fourth quadrant. So in the fourth quadrant I can write 320 as 360 degrees minus 40 degrees, which would give me 320. Then I have cos 20. I'm just going to leave it as that for now because it is already an acute angle. Then I have plus sine of 140 degrees. 140 degrees is in the second quadrant, and I can write angles in the second quadrant as 180 degrees minus the acute angle that would give me 140. Then we have sine of 200 degrees. 200 is in the third quadrant, and in the third quadrant I write my angles as 180 degrees plus the acute angle that would take me to 200, which is 20 in this case. Applying the reduction, cos in the fourth quadrant is always positive, so this reduces to cos 40 degrees. Then I still have the cos 20 degrees plus sine on the second quadrant is always positive. So the first factor there reduces to sine 40 degrees. And then sine in the third quadrant is always negative. So this would reduce to negative sine 20 degrees. Distributing this negative, or just multiplying it, simplifying this, sorry. I've got a positive times negative, so that makes us all negative sine 40 degrees, sine 20 degrees. Right, so we've used reduction formulae, we've changed the angles, and what do we have now? I have the same angle 40, and I have the same angle 20. I still have cos, cos, sine, sine, so I'm still looking at a cos compound angle formula. And what do we remember about the cos angle formulae? I use the first angle first and the second angle second, but what sign do I use between them? Remember, in cos the sign changes, so I'm going to have a minus in the expanded form but a plus in the contracted form. Right, cos 40 plus 20 takes us to cos 60 degrees. 60 is a special angle, so now we need to remember our special angle values, and there are different ways that you can remember them. One that I really always fall back on is the use of the triangles. So if I have my triangle with 60, 30 and a 90-degree angle, I know it's 1, 2 and root 3, if you remember that. And then cos 60 is adjacent over hypotenuse relative to the 60-degree angle, so which is a half. So that is the value without the use of a calculator. Right, another example where we don't use a calculator. And now all we have is sine 75. Sine 75, 75 is not a special angle, but we are looking at compound angles, and which means that we can potentially write 75 as the sum of compound angles. Okay, now 75 is the sum of 45 degrees plus 30. 45 and 30 both being special angles. This is a compound angle. We can use our compound angle formulae to expand this. Right, sine, if I have a plus, goes to sine 45 cos 30 degrees. I keep the plus. Then so I have sine cos, the second term I have cos sine, so it's going to be cos 45 now, and then sine 30 degrees. Now I use my special angle knowledge, and in this case I like to use the triangles to remind me of the values. So I've got 60 degrees, 30 degrees, 90, 1, 2, root 3, and I'm also needing a 45-degree angle. So the 45 and 90, and the values are 1, 1, and root 2. Okay, so now I can use my triangles to know the values. Sine 45 is opposite over hypotenuse, so that is 1 over root 2. Cos 30, so relative to the angle 30, it's adjacent over hypotenuse, so that is root 3 over 2, plus cos 45, so relative to the 45, it's adjacent over hypotenuse, which is 1 over root 2, and then sine 30 is opposite over hypotenuse, so opposite over hypotenuse, which is a half. Simplifying this, I'm going to multiply the fractions. So in the first term, I have root 3 over 2 root 2, plus the second term, multiplying my numerators, I have 1, multiplying my denominators, I have 2 root 2, and we have the same denominator, so I keep that denominator, and the numerators I can add, and without a calculator, that would be my final answer. Right. We get to the slightly more complex type questions. Okay, so just a note, okay, if you have prove or show that question, so show that is the same as a prove question. It means that we have to split up the statement into its left-hand side and the right-hand side and work separately with each side, simplifying them to show that they are equal. And if they are equal, we have proven the statement true. Okay? Hence means use the previous question. And if it says hence, you must use the previous question. Okay? So let's look at this question. For A, it says, show that cos 60 degrees plus theta minus cos 60 degrees minus theta is equal to negative the square root of 3 sine theta. Okay, so we need to split this up into our left-hand side and right-hand side and work with them separately. Okay, so my left-hand side is equal to cos 60 degrees plus theta minus cos 60 degrees minus theta. Okay, now these are compound angles, so I can use the compound angle formula to expand them and see if that helps me simplify them. So cos 60 degrees plus theta, okay, the cos compound angle formula gives me the cos plus a sine term, and we just need to remember that if I have a plus in the brackets, the sign changes to give me a negative in the expansion. So I've got cos 60 degrees, cos theta, then the minus, and then I have sine 60 degrees, sine theta. Okay, minus, this is the minus that I'm talking about. Then we have cos 60 degrees minus theta. Okay, so in this case, again, a cos, so I'm going to have cos, and then the sine. But I must remember that while I have a negative and a minus in the bracket, I'm going to have a plus between the terms. So I have cos 60, cos theta, and then my plus sine 60 degrees, sine theta. Okay, the reason I'm writing this expansion in brackets is because of this negative. That negative needs to be distributed to every term in the brackets. So let's do that now. So I've got cos 60 degrees, cos theta minus sine 60 degrees, sine theta, minus the cos, the first term, cos 60, cos theta, distribute the negative, which makes the last term negative 2. Okay, Now I can look for like terms, and if we do that, we see that I have a cos 60 cos theta minus cos 60 cos theta. So those cancel each other out, and then I have minus sine 60 degrees sine theta minus sine 60 degrees sine theta. Now these are exactly the same, so they are like terms. So it's like minus an apple minus another apple. How many apples? Minus 2 apples, and the apples are sine 60 degrees sine theta. Okay, now this is not quite yet the right hand side. We've got the sine theta of the right hand side, but not this yet. Okay, but what we can do is find the value of sine 60. Now if you know your special angles, sine 60 is opposite over hypotenuse root 3 over 2, and then sine theta. Simplifying this, the 2's cancel, and we're left with negative root 3 sine theta, which, what do you know, is our right-hand side. And we finish the proof by saying equals right-hand side. Okay. Sometimes you will have to work on both the left-hand side and the right-hand side to simplify them to the same value. Sometimes you start with the right-hand side and you work it to be the left-hand side. So you're not limited to always have to work with the left-hand side. It just worked well in this example. Okay. Now if we look at question B, it says hence, which means we have to use question A, evaluate cos 105 degrees minus cos 15 degrees without using a calculator. Okay, just going to change my pen color here. Okay, now how can we use A to solve B? Okay, so if I compare them, I have in A a cos of an angle minus cos of an angle. I have that in B too, cos of an angle minus cos of an angle. Okay, so if I can rewrite cos 105 degrees minus cos 15 degrees in a similar way to how it is written in A, I can use the right-hand side of A to help me calculate B. I hope that makes sense. Just rewind if you need it explained again. Okay, so cos 105, I need to write as 60 degrees plus an angle. Cos 15 degrees, I need to write as 60 minus an angle. Now, 60 plus what gives me 105? 60 plus 45. So I've got cos of 105 degrees, just writing it out, cos 15 degrees. Okay, this is the same as cos 60 degrees plus 45 degrees minus cos. Now in the second term, if we look back at A, I have to write it as 60 degrees minus an angle. Now 60 minus what gives me 15? 60 minus 45. Okay, so the only difference to A and B is this value of theta, and in this case my theta is 45. Okay, so where I have theta in A, for B I just need to substitute theta with 45. Okay, so if this is the left hand side of the expression in A, it equals the right hand side, which is negative root 3 sine, and my theta in this case is 45 degrees. Okay, now 45 is a special angle, so I have negative root 3 sine of 45 is 1 over root 2, which simplifies to negative root 3 over root 2. Okay, if we rationalize our denominator, just a quick recap, I would have to multiply it by 2. What I do to the bottom, I do to the top, and that gives me negative root 3 times root 2 over root 2 all squared, which is just 2. And of course I can, if I'm multiplying surds with the same roots, I just multiply what's under the third, so that's 3 times 2, which is 6 over 2. Okay. Right. One more. Show that example. Okay, and this is an if-then type question. So if we just read this, let me take away that big ugly circle. Show that if sine theta plus 60 degrees is equal to 2 sine theta, then tan theta is equal to root 3 over 3. Okay, so this is not a prove or show that type question where you split up the left-hand side and the right-hand side. In this case, you take the if part, okay, and you have to simplify it to show that it equals the then part, okay. So we start off with the if. So if sine theta plus 60 degrees equals 2 sine theta, okay, we need to work with this simplifying as much as we can to show that we get the then part. Okay, so if we look at this, I've got sine theta plus 60. It's a compound angle formulae. We can try expand it and see what happens. Okay, now sine compound angles expand to a sine, cos, sine in that pattern. So I've got sine theta cos 60 degrees. Then remember, for sine, the sign doesn't change. So I'm going to keep the plus from the brackets. And then I have cos the first angle, sine the second angle. And that equals 2 sine theta. Okay, not quite the then part yet. Let's keep going. Cos 60, sine 60, I can find the value of, because 60 is a special angle. So I've got sine theta and then cos 60. Cos 60's value is a half. Okay, so this is sine theta times a half, plus then I've got cos theta, and the value of sine 60 is root 3 over 2. Okay, let's just write this as with the coefficients first. Okay, now if we look at this, I have a sine theta in this term and a sine theta in that term, which means that they are like terms. Okay, so if I subtract a half sine theta, I'm left with root 3 over 2 cos theta on the left hand side equals 2 sine thetas minus a half sine thetas, leaves me with 1.5 sine thetas, which I can write as 3 over 2 sine theta. Okay, still not yet my right hand side. My right hand side has tan. Now from the identity we know that tan theta is equal to sine theta over cos theta. Okay, so if I want to change from having a sine and a cos to tan, I need to divide by cos theta. So if I divide by cos theta, I'm left with root 3 over 2 on this side, and 3 over 2 sine theta over cos theta. Okay, now I want tan on its own, so I'm going to divide by the 3 over 2. So if I have root 3 over 2 and I divide by 3 over 2, I can tip in times to be multiplying by 2 over 3. And then the sine theta over cos theta give me tan theta. Simplifying the left-hand side, the 2's cancel, and I'm left with root 3 over 3 equals tan theta, which, if I just write the other way around, is my then part. So we have shown it. Right, a last comment that I would like to make is there are exceptions to using the compound angle formula. And that exception is, do not use the compound angle formulae if you can use the reduction formulae or co-ratio functions. Okay, so just remember that cos 90 degrees minus theta, we know as a co-ratio reduction takes us to sine theta. But 90, cos of 90 minus theta is of course also a compound angle. So remember that our reduction formulae